So yeah, good morning everyone, and thank you for being here. As Paulo was saying, the title of the presentation is Ports as Engines of the Hydrogen Value Chain in the Blue Economy, and focusing on the Hy2Fish project. So we wanted to share our approach to the decarbonizing trends in this strategy for decarbonizing fishing and the maritime industry. So that's why I decided to share this project, this Hy2Fish project. As you will see in the following slides, this project is focused on finding solutions for decarbonizing the fishing fleet and identifying all the challenges that a vessel owner may find along the way, which are many and with not such an easy or simple solution. We, the Port of Vigo, we have been working with the idea of the blue growth and blue economy since 2016, which is the year we developed our blue growth strategy. We were the first port in the Spanish port system to have a comprehensive strategy in terms of blue growth. And nowadays, everything that we do, almost all of our projects and our investments are led by this blue economy soul, let's call it. As part of this strategy, we have been developing projects aimed at achieving sustainability from a triple perspective: the social, the economic, and the environmental. And this includes all initiatives and actions responsible for the sustainable growth of the hinterland of the port and the sustainable development of port cities. We try to match always the blue port with the green city. It's a port city approach in all our activities. We have participated in projects that foster different aspects of the maritime industry to achieve this sustainability, like learning courses to improve the professional capabilities of seafarers and fishermen, infrastructure projects to develop nature-based solutions for ports, energy optimization of ports through building solar photovoltaic plants or improving the thermal enclosure of the buildings, and many other activities in this sense. And obviously, the decarbonization of fishing vessels. We, the Port of Vigo, are coordinators of the Pillar 1 of the Atlantic Strategy. And from that aspect of our work, we have been promoting with DG Mari the development and construction of demonstrator vessels, both for port services and for fishing. One of these initiatives is this Hy2Fish project, which is financed through HYDEA and has a total budget of 2.2 million. The maximum budget of this call was around 2.5, so we are not in the maximum of the budget, but we were close to it, and I'll explain why later. The objective was to fund a single pilot demonstration project to promote the energy transition in the European fishing sector. This project required the transformation of an existing fishing vessel measuring between 12 and 24 meters, and this is another key idea, using the most innovative technologies currently available in the market for decarbonization. And why I say that this is key, between 12 and 24 meters? Well, 2.5 million is not a lot for a fishing vessel that you have to buy. You have to transform and implement all the technology. And then this fishing vessel won't be able to fish commercially anymore. It will be a demonstrator forever. So the budget is quite tight for achieving this. And we had to go for the, let's say, the smaller end of the range that the call allowed us. Proposals were accepted until June 2024, and the call was resolved in September 2024, selecting a consortium led by ARBI, which is the vessel owner cooperative, the fishing vessel owner cooperative here in Vigo, and we, the Port of Vigo, are part of the consortium. Actually, we will be hosting the vessel when it's finished, all the implementation of the new technologies. We will be hosting the vessel for the rest of its life. The project started officially in January 2025. The project, the Hy2Fish, focuses on the most promising and scalable technologies that are characterized by low capital expenditure. I mean, we need to invest the lowest amount of money to try to achieve the maximum decarbonization of the work that the vessel is intended for. This initiative aims to integrate solutions like enhanced hydrodynamics, advanced electrical power management systems, optimized low noise propellers, solar electricity, full electric propulsion, sensing and digitalization technologies, and hull appendages to improve the hydraulic behavior of the vessel. You can see here the original vessel, the Julia Pico. Although it doesn't look very impressive, consider that the call established that the vessel had to be between 12 and 24, as I explained. So not a lot of margin for buying a big vessel. The main characteristic of the vessel are shown in this slide. It was located in Valencia. We bought it there. It was ready for the Mediterranean Sea, so it will be adapted to the Atlantic conditions, let's say. It's a fiberglass vessel, so it has some advantages in terms of that is easy to transform and adapt with the new technologies, but it has also some problems because steel is more resistant to any harsh weather conditions. Also, it has a rather small engine with 65 kilowatts and 12.64 meters in length overall. And now this slide shows almost all the technologies that we're going to implement in this vessel. First, innovative bulls and spray rails enhance hull hydrodynamics, reducing friction and noise. So this is working with basic shapes and improving the general behavior of the vessel for Atlantic waters. Recyclable thermoplastic composites for maritime applications. Air lubrication with tech cutting drag and boosting efficiency. So this is a technology that what it does, it puts bubbles of air in between the water and the vessel, in between the water and the hull, and it reduces the drag. And this is a very tested technology in other fields like windsurfing, for example, but it's very innovative for a fishing vessel. The propulsion system is based on electrical solutions. In a simple approach, what we'll have is two lines of powering the axle, powering the propeller. One will be solar panels, batteries, and the electric engine connected to the gearbox. And then on the other side, on the other line, we'll have a Wankel engine working with hydrogen and connected to the same gearbox. So both technologies will be decarbonized. It is also completed with hydrogen power modules and battery pack optimized for cold weather and with a high percentage of reusable and recyclable components. Integration of multifunctional optical fiber sensors for fishing ships, low weight, cloud-based eco-driving software that optimizes the routes to cut fuel use and emissions, and then BMS, EMS, and PMS to optimize the energy consumption of the vessel. The overarching goal of the Hy2Fish project is to develop procedures and technologies capable of reducing fuel consumption and greenhouse gas emissions by up to 40% compared to conventional vessels, obviously. When powered entirely by renewable energies, we could achieve 100%. But that's the path that we're following. We still need to test these technologies, demonstrate them, make sure that they have no issues in terms of stability or safety, and then we will improve the percentage of decarbonization. What I'm trying to show in this slide, this is kind of trying to understand the overall approach to the use of hydrogen and the hydrogen value chain. There's a structure interconnected projects addressing the energy transition in the region and beyond. Together with the HYDEA, we have Julio Verne and the Hy2Fish, which demonstrate how ports can act as key hubs in regional hydrogen value chains, enabling integrated hydrogen supply chains and fostering strategic partnerships with industry. It makes no sense having production of hydrogen, that would be the supply, if no one needs that production, that would be the demand. So Hy2Fish will be the initial demand that we need to start the value chain. With it, the Julio Verne project will solve the supply. This Julio Verne project is a project that will develop a hydrogen production facility with a hydrolyzer and storage facilities inside the port. It will be ready to supply hydrogen in small quantities at the beginning, both to vessels and to land transport. In the next phase or stage, we will try to include in this hydrogen strategy all the forklifts and transport inside the port and all the machinery of the port, so we continue decarbonizing the port operations. All these tasks will have an approach focused on replicability and scalability. That is, we want all these technologies and solutions to be used in an efficient port with a reduced and controlled investment and with high rates of efficiency. These three projects, which are the core of the global hydrogen strategy of the Port of Vigo, involve many companies and stakeholders, as you can see in this slide. For the Julio Verne project, the one on the left, many local SMEs have participated in the design and development of the solution, and most of them lie in less than 10 kilometers from the Port of Vigo. The HYDEA project has a different scope or regional approach, covering the countries of the Atlantic region, and the Hy2Fish project has even a different coverage with partners from the Mediterranean and also northern countries. What I'm trying to explain here is that collaboration is the fundamental element of any of these projects. We need to share knowledge and technological advances so we can progress in the decarbonization of the maritime and fishing industry. One of the messages that we're giving the EU through the Pillar 1 of the Atlantic Strategy and through the ETP, the Energy Transition Partnership, is that we as ports need more direct and fluid communication channels so we don't lose time and money testing solutions that someone else has already tried and demonstrated. Either its validity or failure, but we need that communication. We need that share of knowledge. This almost final slide explains the expected conclusions of the Hy2Fish project. Ports as engines of the energy transition. This is very similar to the motto of the Pillar 1 of the Atlantic Strategy, which is ports as hubs for the blue economy. We have a key role as ports to promote solutions, helping in any way we can, that lead to the decarbonization of the fishing industry. We have the space, we have the energy supply facilities, the regulations and tariffs that affect our port. So we have many ways of pushing forward all the stakeholders involved to reach our goals. Technological innovation in the fishing sector. Well, the Hy2Fish project is focused on this aspect, the technological aspect. A strategic industrial partnership at regional, Atlantic, and EU level. As I explained before, there is a strong need for collaboration and knowledge share among ports and institutions that can lead to the right regulatory frame for the decarbonized maritime industry. Regional value and European replicability. Again, as said before, all these technologies and solutions are intended to be replicable and scalable so that they can be deployed in most of the ports. And the integrated hydrogen strategy. Supply needs to meet demand. And that's it. Thank you very much.